Good morning to all. So in this demo we are acting as network operator which is receiving electricity consumption data from our sensors, and by Microsoft Cloud Services and Azure applications we generated real-time data flow that we are able to connect our sensor and, for example, Power BI. So in the Power BI we of course did visualization with the real time that the customers and service provider are able to get better accurate data when they are looking their data. And then we are of course use Snowflake as central data warehouse platform. And the data that we are using is from the Raspberry Pi, which is on that table. We have a couple of sensors in it, but we are modeling the actual electricity consumption, so we are not using actual smart meter readings.
All right, so this is the setup that we have for this demo, and obviously this is just one configuration. You could achieve the same result with different services or with different data flows. Like you could, here we have the Raspberry streaming the data to IoT Hub, but it could go straight to Blob Storage, for example. So the Raspberry is sending this small Json telemetry once a second to the IoT Hub, and the hub acts as a gateway to the cloud in this scenario. So in the service you can provision devices and you get their unique connection strings, which you then use in the script which sends the data in. And the IoT Hub is quite capable. You can provision millions of devices, and at the top tier you can handle close to 300,000 messages per minute per device. And you can scale it up and down on the fly. And you can send cloud-to-device commands, you can monitor and diagnose your devices. And you can route the data to different endpoints like we have done here. So all of the data that comes to IoT Hub gets sent to one of these three paths. And the purpose of the first one that you see up there is process automation. So the IoT Hub detects if the sensor reads abnormally high temperature, or it detects that the sensor is inactive. So then that specific message gets sent to that route. And then what happens next is that logic app is triggered, which then as a result sends an email, in this case to me, about a sensor failure. And the logic app is pretty simple service used for process automation, and you don't actually have to program it yourself. You can just use this pretty simple drag and drop user interface. And then we have this path number 2, which purpose is to store all of the incoming data to our central warehouse, which is Snowflake in this case. So the IoT Hub batches the incoming messages in this case 100-second intervals, and then it stores the raw JSON into the Blob Storage. And then we have the Snowflake, and probably many of you wonder how easy it is to integrate Snowflake in the Azure architecture. And the answer is it's super easy. So when you create your Blob Storage, which is the same as S3 in AWS, you get a connection string or SAS token where you can define all the different permissions for your token and start date, expire date, and so forth. So then you take that string and you go to Snowflake and create an external stage with the string, and then the connection is open and you're free to move data back and forth manually or automatically. And I'm going to show that later in more detail. And then Kent already covered a lot of the key benefits why we have chosen Snowflake here instead of some Azure native database. But so the connectivity is really important, and then like Kent mentioned, there's a lot of different connectors and drivers to it. For example, here I have done this function app with the Nodejs Connector, and what it does, it executes SQL inside Snowflake automatically, and in this case it's copying the new JSON data that comes into Blob once an hour to the Snowflake. And that could be instantaneous as well, but in this case the 1 hour was deemed enough. And then the pricing, as was mentioned, it's by the second. So for example here, the function app uses Snowflake's compute to execute the queries, and the query takes like approximately 1 minute to execute. And that means after the 1 minute the billing stops, and that's it. So at the lowest level I think you can auto suspend your warehouse after 1 minute after executing the query. So it's really instantaneous, and as said, you're free to scale it up and down. If you want to quadruple the size of your compute cluster, you click one button and it happens in 2 seconds, and the other way around, the same speed. And then it really simplifies the architecture, because all of the data in this scenario is in Snowflake, and you could integrate also your on-premise data warehouses with Snowflake. The live data sharing with partners or customers is really easy. And in Azure, we don't do any data transformation, so the JSON is transferred in Snowflake, and it's really easy. For example, myself, I don't have a big background in dealing with JSON or even SQL, and I've been handling a really big JSON files with really deeply nested structures and big file sizes, and it's super easy in Snowflake, and I'm gonna show that later as well. And then we have this machine learning AI data science block here, which many of you are probably interested, and doesn't represent any specific service in this photo, but just to mention like how Snowflake plays with it. So as you have all of your data, like Snowflake is a data lake as well as a data warehouse, so you have all your data in one location, and you have a lot of connectors natively in Snowflake, and you can deal with semi-structured data really well. So whoever needs to use the data for their analytics needs and whatever the application or software is, all of the data is in Snowflake, and it's really easy to import it to your specific service. So for example, if I would have a machine learning studio in Azure here, I could just load the data into Snowflake, transfer it there, and then either manually move it back to the machine learning studio as the data set, or rewrite this function app to do that automatically in the other way around. And then we have this third data path, which is the live data streaming to Power BI, and Tuomas, tell us about that.
So we generated our live data path with the Stream Analytics, which is Microsoft event processing engine. So we wanted to connect our IoT hub and our Power BI, and like I say, we wanted to make better graphs, real-time graphs that, for example, the company is able to act more fastly to the problems that arise. And then, of course, the machine learning studio could be also linked to this, so you could stream data from the Stream Analytics to Blob Storage, then put it to machine learning studio, and after that visualize that in the Power BI. So next, Sami is going to talk a little bit longer about the IoT paths 1 and 2, and then I speak a little bit more about the path 3, and then we have last little demo about Machine Learning Studio.
So I'm not going to go through all the different menus and stuff, so if you have questions about something, just ask. So yeah, this is the dashboard that I have for this demo. So you have your favorite services on the left, and then services used in this demo. Up here, you have some pinned services like the IoT hub here. You can see the daily messages sent through it out of your daily quota, and some relevant metrics like the telemetries that the Raspberry is sending to the hub. And here in the other metrics, you can see the amount of events that the Stream Analytics processes from the IoT hub. So first we could go here. And all of the services kind of look the same on the front page, so they have a lot of similar menus on the left, and then you have the service details in the overview, and some of the metrics you might want to see about the service. And all of these you can pin to your dashboard if you wish. So then you have like access controls where you can control different user groups and policies who can use this service and what accesses they have. Then, as I said, you can scale this up and down on the fly and provision more units if you wish to do so. The one cool feature in Azure is this, that it automatically generates a JSON automation script for your service. So all of the settings I have put here, the Azure now automatically generates to this template. So if I would need to deploy a lot of similar services many times, I could just copy it here and then deploy it from like Azure command line tool or something like this. And you're of course free to change the settings here as well. Then if I would have more expensive tier of this, I could query the incoming messages with SQL, all of the stuff that is going through the hub. Then here I can provision the devices. So for example, this is the Raspberry. And one device doesn't mean one sensor. You could have many of the sensors hooked up to one device, or you can have one device on one sensor on one device. So for the connection, all you basically need is this connection string when you make a new device, and then you use that to authenticate with the hub.
One question of this automation script, I noticed that you have this snow pipe defined there. Is it directly also connected to Snowflake via this hub?
No, it's not. It's the name of my function app actually.
Okay.
So it's not directly connected with Snowflake. So yeah, here you have the IoT Edge capabilities. And the message routing here is the key feature. So in here I can define custom endpoints. So I have defined the different service bus queues, and then I have the blob storage. And here you can see, for example, the batch frequency, how often it batches the messages to the blob storage, and what's the file format and so forth. And then after creating the endpoints, you create different routing logics. So here, for example, is a route that says that anytime a message comes to the IoT hub where it detects that the sensor is inactive or the electricity consumption is 0, then it sends that message to the queue. And the other routes do other stuff like send the data to blob storage or trigger different kind of alerts and so forth. Then we have the service bus queue, which is like SQS queue. There's not much to show. It has pretty much the same options in the service, and all you need to know is that when you create the queue, you can define different options like how many days the messages are retained in the queue, and do you want to enable dead lettering, and what happens after the expiry date? Do you want to delete the messages or, for example, store them for some reason in the blob storage? But so in the first path now we're going to the logic app which triggers the email sending. And I could show this first. Here I have the telemetries that the sensor is sending to the cloud, and now if I block one of these sensors, it should send me an email almost instantaneously about a sensor failure. So let's see if a demo effect happens. Right now it was false. Now there should be a message coming in some seconds. So yeah, now it says that the sensor is down. So you can see the data flow is pretty instantaneous. And you can add all kinds of dynamic content to these messages. So now the email just picks up the message content. You can see that the electricity is 0. It says what the timestamp of the alert is, and maintenance is required. But anyway, so the logic app looks like this. The designer, as I said, is this drag and drop interface, and right now it's super simple. So all I have here is a trigger. So when a new message is received in a queue, which is the service bus queue, here I have specified the queue name because I have a couple of them over there. And I'm checking for the new messages every 5 seconds. And so if the condition is met, then an email is sent. And that's it. This is pretty much the simplest app you could make, but then if you wish, you can make pretty complex stuff in here to like add parallel action branch and expand this to go look like a big flow chart. So that was the email ticket sending. So now I'm gonna show you the storage account. And many times when you talk about Azure, you talk about blob storage. So the blob storage is actually a blob inside a storage account. So this is my storage account for this demo. And inside I have different kinds of blobs. So if I go here, this is the blob that all the data that the Raspberry is sending in. And currently there's like 1.5 million JSON files in here in this really long path to the files because it's storing everything once per second. And here you can see an example of one of the files. So it's this really simple JSON. So about connecting to Snowflake. So here is the shared access signature that you're going to use when you want to create the external stage that allows you to copy the data to Snowflake or import data from Snowflake to Azure. So you create a token and you can define different kinds of permissions, like if you want to create tokens for different users, like if they have read, write, delete permissions and so forth. Then you have start and expire date. And this token is on the storage account level, but you could even generate this token for a specific file if you wish to do so. So it's pretty flexible. And then I'm gonna, I could maybe show the function app as well. So as I said, this is using the Nodejs Connector that Snowflake provides. And what it does is just executing a copy into statement inside Snowflake. And it was pretty simple to make. I just write the script and install the dependencies on my computer and uploaded it with the Azure CLI. And this is like AWS Lambda, so you have the serverless functions here. You're free to do it in many different languages. Python at the moment is in preview, so I had some problems deploying that, but since it's in preview, I'm sure it's going to come as a full supported language pretty soon. So you see the script here. Oh wait, I have some passwords there, so I'm not going to show it. And then you have these platform features here, like you have the debugging console and some tools to modify your script here as well. Right now I'm not sure what it's loading about, but so let's jump into Snowflake. And all of the commands here are done in the worksheet with the SQL, but everything you could also do with the graphical user interface. But I like to use the SQL more. So here you have the external stage. So this is all you need to do to basically integrate Snowflake. So you use the URL to point to the specific blob that your data is in, and then you use your credentials, which is the SAS token that we could have just generated. So all of this takes like probably 10 seconds if you know what you're doing. So then now we have opened up the connection between the two. So I'm going to just show some simple queries. So for example, the basic stuff, I can list the files inside the stage. And I went a little bit deeper into the file path because I don't want to list all the 1.5 million files here at the moment. But here I can see the files that are in the blob. And okay, this doesn't make much sense yet. But then we can also query the files directly from the stage without copying them to Snowflake. So now I'm choosing the first column of the files that I have there, and it's the JSON column. So now I see here the telemetries that are sent live here, and they look like this. And then I can even use this path notation to a little bit transform and look at my data in the stage already. So now I just chose a couple of values from the JSON with the keywords without even moving the data. So I have timestamp and the office temperature. Then here I have the copy in the statement that the function app is executing once an hour. So I'm selecting the first column, which is the JSON from the files. Then I'm using this system parameter metadata, so I get the file name, and then I'm using a timestamp of the time of the copy. So when the data gets copied in the raw table, it looks like this. So as Kent mentioned, you can have semi-structured data, normal data in the same table. And for example, here too, if I wish to do so, I could have XML, any kind of stuff in these variant data type columns. And so yeah, I have the JSON and the normal data in the one table now. So then what I'm going to do is I can use this key, I don't know how you call it, but I pick the keywords inside the JSON to just simply select the stuff I want out of the JSON. So the column, my variant data type column is called JSON. So here I select that column, and then I just select the key to the values that I want. And you could also do this already in the copy into statement, but as Snowflake stores the semi-structured data in the variant data type, it's convenient to copy it in as a raw data and then transform it here. So then I just execute my statement, and all of the data I had in that table is now here in the relational table. And obviously in this example, the JSON is really simple, but the same logic applies even if you would have really deeply nested structure. So you just follow the path to the key files and use it in basic SQL to get the key values.
Pulls the newest data.
I can really quickly demonstrate how you would, for example, connect it, a view with Power BI, for example. So here, so let's, for example, create this view. It's creating the view on top of the same raw data that I was just using. So now I have the sensor readings in this kind of view format. So now when I go to Power BI, I just go to get data. And then we have Snowflake here as one of the options. Then here I need my server and the warehouse. So now here you see the table that we just created. I mean the view. And this is basically what you need to do to connect. And now it's just a view on top of raw JSON. And here it displays as a full normal table, and you can do all the stuff that you could do with a normal table. So now it's uploading. I don't remember how many rows was it, but anyway, as it's done uploading, you can see the same view as we have in Snowflake. You can have it here. Now I just did an import because I wanted to show you the table is actually here, because in direct query you wouldn't see this, but now here we have the same sensor readings. And now since it's a view, and during the next hour when the function app is again copying the data into Snowflake, if I come here and click refresh, all of the new data is going to be here as well. Okay, this was a little bit extra, but then I think Tuomas is going to show you about the live data streaming with the Stream Analytics and Power BI.
So yeah, I'm going to talk about Microsoft Stream Analytics, which is, like I said, event processing engine. So its methods are track and analyze massive amounts of data from the data source, and it's especially good if you are monitoring remote data from the remote source. So in our case, we just wanted to connect IoT Hub and Power BI, for example, but you could also do information extraction or identifying patterns in Stream Analytics. And that way you could make triggers or alerts for it. It supports CSV, JSON, and Avro data forms, and you are able to connect multiple different data sources into it. So here is the overview of the Stream Analytics. So you can see your inputs and outputs and the query that you are using, and also you are able to monitor the ongoing data or utilization %, etc. So one of the key capabilities of the stream analytics is that it's very easy getting started with it. So the first you just select inputs, which is in our case our IoT hub. It could be also event hub in here Azure. So you select that, then you select your output, which is Power BI's in our case, but this could be pretty much any storage account like Blob Storage. After that, you write very simple query. So all you need is just to select all with the star and write your into and from locations. After you have done this, you just go back to overview and start running the program. So other key capabilities of the stream analytics, it's that it's fully managed, so you don't need provisions or machine clusters to run it. The performance is good, so over 1 million events per second with the low latency. And then it's quite reliable, so there is recovery capabilities with this. Also, if you want, you could additionally join Machine Learning Studio into it to train model from the historical data, or you could use Azure function to make code to find patterns, or for example, service bus to make triggers and alerts with it. So after you have started the stream, you should find your dataset in the Power BI, and I little bit pressed our temperature and humidity sensor. So you can see that in this live data dashboard that the action is immediate. So in the Power BI, we of course wanted to make visualization dashboards with the real-time data, so that the data is more useful for the people. So here we are monitoring electricity consumption, temperature, and humidity. And this could be very useful, for example, if there has been some kind of problem with the electricity consumption, so the company people can come here and check, for example, last 30 minutes what has happened. Then I have
Sponsor guide. It is this elasticity that is built into the product. Seems to be. Auto suspend.
Yeah, nice demo effect. Then I have my next dashboard. This could be, for example, customers. So I have modeled the smart meter here in the picture. You can see in the screen the current electricity consumption. Then I have some key performance indicators here. So you are able to see with the goals, the temperature and electricity consumption. I have some average electricity consumption meters also here in the down. So here is by minute and hour. So here we have like yesterday, so you are able to get summarized data in that hour. And also here we can probably see that we had internet connection error at some point, so the data probably went to the 0 at some point. So then we also have temperature alert here. So if the temperature goes over 25 Celsius, I get notification to my email and also to dashboard, like you can see here. Then I have a relation table with all my variables, so temperature, humidity, and electricity consumption. So here the data is quite linear, but for example, in some kind of industrial process, like some chemical process, you could follow like pH, redox potential, and time, for example, and it could be very useful to make this kind of graph. And then of course I have a donut chart because they're so nice looking. And here I'm just seeing the relation of average electricity consumption, temperature, and humidity. And lastly, I have utilized maps to make one dashboard. So here if our smart meter would also send GPS locations, I could see the locations on the map. And for example, here, if there would be some kind of problem, I could see the red and see the location, timestamp, and the, for example, average electricity consumption currently. Of course, this is just a small scenario, so this could be globe, and you could see all the location through the world, and then you can see that there is some kind of problem in Europe, so you can go look in the map and make some conclusion why that would be. So now we have pretty much talked about all our steps, so alerts, the storage and Snowflake path, and the live data path. So now we have little demo about Machine Learning Studio.
We didn't dive really deeply into the Machine Learning Studio, but just to show you, many of you are interested probably in the Azure, that specific service, so just how the service looks like and what it could do.
So this Machine Learning Studio was quite last time addition to this event, so this is going to be quite light take on the infrastructure of the Machine Learning Studio. So in the Machine Learning Studio, like someone you might know, you build your model with the different kind of blocks. So you can find the blocks on the side, and in our case, we wanted to make linear regression model about our office temperature. So, of course, first we wanted to select our data set, which was from the Snowflake, but this could be pretty much from anywhere. So, in our case, from Snowflake. Then you of course want to select the right columns in the Machine Learning Studio, so you select column blocks for it. Then you are also able to write Python and R script into it. So in our case, we made a couple of time variables which measure our model better. Then there are some split data columns, split data blocks also, but the idea is to steer all the blocks in the train model. So after you got everything to train model, you want to add your models, so linear regression in this case, and then run the system. So this is not run. Okay, this is different than yesterday.
I think somebody has modified the set without us looking.
Was this the same we used yesterday?
No, it looks different.
Yeah, but did you open the...
No. But anyway, like a real life use case maybe for this would be that you have thousands of these sensors streaming the data all the time as JSON to the Snowflake. And then since you have so good connectors there, you could write your Python script here to do the data transformation, for example, and import the data set into this model and then train your whatever you use, like here regression or some machine learning algorithms, and then maybe forecast the electricity consumption, for example, and then in the end export the data or the result data set to whoever needs it, to Power BI or any kind of service that you want to look at it. So it's not working.
Yeah.
Was that all?
Yeah, that was all. So
Yeah, I think that.
One question. So why would